Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za.
Talk Radio.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
Chris Smith, good morning. Welcome to it.
Good morning, Udo, and Happy New Year to you. We haven't spoken in 2014, have we?
Same to you, of course. Now, I want to get to as many of our listeners' questions as possible. I had one at the top of the show, though, because South Africa has a space agency. The space agency has gone on record saying that the expected coronal mass ejection, which our news department has described as gas bubbles from space, will not have any impact on things like radio frequencies and satellite signals. They've given us that guarantee. I just want to know, how can they? How would they know what the impact will be back on Earth, back in South Africa?
Well, do you know, Britain is one of the few countries in the world who in the last couple of weeks have announced that they're now producing space weather forecasts. Would you believe it? And what determines the weather in our cosmic neighbourhood is the activity of the sun. And what happens is that the sun, from time to time, goes through periods of convulsions where it ejects more matter than it would do normally. Yeah. Because streaming away from the sun all the time is this maelstrom of charged particles and radioactive material, which goes zipping past the Earth at maybe 1.5 million kilometres an hour. Very, very high speed. And most of it is deflected around the planet because we have a magnetic field. But from time to time, the sun burps up a bigger dose of radiation, and we call this a coronal mass ejection. We don't know exactly why this happens, but we do know that the sun goes through various stereotypical changes in its behaviour immediately prior to this happening. So we know when the sun is going to do this, and I think scientists are beginning to build up a picture of how the variables compute. So in other words, if certain things happen in a certain sequence to a certain scale, we can say that the ejection will be bigger or smaller. We also can then look at which direction it's tending to come in, because it won't happen all around the sun. It will come from one position on the sun's surface and therefore go out in a cone spreading out from that part of the sun. If the Earth overlaps with the path of that material, or at some point in its orbit will interact with that material, then we're going to get a bigger dose. If the Earth has a low chance of being in the way, then we're going to get a very small dose. So you can forecast what will happen to the Earth, and when this radiation arrives, as I say, most of it is going to be fended off by the fact that we have this powerful magnetic field around the planet, and so there will be an intense northern and southern aurorae. Those are the lights that you see in the sky caused by this material interacting with the magnetic field. But also things up in space can be impacted, and this can include the International Space Station and the astronauts who are on there. Yeah. It can also include satellites that are zipping around the planet, because they too, having electronics in them, will be vulnerable to this effect. Okay. And also people flying around the planet in aeroplanes. Aeroplanes, when there are big periods of solar activity, will fly at a lower altitude because they can use the atmosphere of the planet as a shield to fend off most of that radiation hitting the passengers on the aeroplane. Okay,
my question out of the way. Let's start with Andrew in Pretoria. Andrew, good morning.
Good morning there. I've got a question concerning evolution. I understand the natural selection process where a creature or a living thing will lose the genetic material eventually. That's of no use to it. My question is the first part of the evolution, getting to a complicated creature from a simple thing. Except for the process of beneficial mutation, is there another mechanism that scientists think was followed for this to happen?
Hello, Andrew. Well, the idea of evolution by natural selection is that, exactly as you say, that there's a selection of genetic material that favours an individual. So let's just explore how this happens. So when I reproduce, then I pass on to my children my genetic material mixed with my wife's genetic material. And so there's been my genetic material split in two. So I give half of my genes to my children, and my wife gives half of her genes to our children, and that means the child has the combination of the two people's genes. So there's immediately a diversifying effect there, because we've mixed sets of genes together that have never been mixed together in that way. Then there's also the process of mutation, because when I copy my genetic material for the process of reproduction, that's called meiosis, then a small number of new changes are introduced into the DNA. And we think that there's between, say, 30 and 50 new mutations generated in every generation when a human reproduces. So I will pass on to my children up to 50 new genetic changes that weren't there before. And the older the father is, the more genetic changes there are. And so that means that then those children are endowed with some changes that may be deleterious, but they may also get some changes to their DNA that may be beneficial. And their genes will therefore make or determine the way their cells work. The cells will determine how they work as an individual, and they interact with the environment around them, and that environment is going to apply a certain pressure to them as an individual. In other words, if you live in a place where there's not much water, and you have genes which enable you to tolerate low water without getting kidney problems or dehydrating too quickly or sweating too much, or you live in an area where there isn't a certain amount of food of a certain type, and so you might run the risk of being vitamin deficient, but you have genes that enable you to make up for some of that deficiency in some compensatory way, or scavenge that vitamin in short supply much better than the average person, you're going to do better. Therefore, you're more likely to pass those genes on to the next generation. And that's largely how we think that individuals, over the period of many, many, many generations, become genetically optimized to the world around them and the pressures applied to them by the world around them.
Great question. Let me go to one on Twitter. Mags Naidu wants to know if the different colors of palms, soles, and lips to other skin has functional purposes.
I think it does, in so much as to put melanin, the dark pigment, into skin is expensive for the body. When the body makes something, it's got to invest energy and chemistry doing that process. And if you invested that energy and that metabolism and your metabolic effort in making something that you didn't need, then it would be a waste. And so the body evolves to only spend money and energy where it needs to. And because the sun doesn't shine too much in certain places and shines more in other places than others, the body is therefore elected to spend its resources on those places where the body is most vulnerable and not so much in the places where it's less vulnerable. I think that's at least part of the equation. And where hands and feet are concerned, because most people don't walk around with their hands upwards towards the sun and the soles of their feet turned towards the sun, they don't need to be as strongly melanized as in people who are walking around with the sun beating down on their forehead or on their face or on their shoulders, for instance.
Okay. Rod in Woodstock, good morning.
Hi, good morning. My question relates to, I think, the first and the third questions you've just spoken about. The first being the magnetic field of that protects us from the solar radiation. After an interesting chat with a guy in a bar over Christmas, he was telling me that is changing from north to south in Earth, and I believe that it's just changed on the sun. Magnetic field has just changed from, well, I don't know, north or south or whatever. And my question is, how long will it take on Earth? Has it ever happened before? And will compasses point to the south eventually?
Listen on the radio, Rod. Nice question.
Hello, Rod. Great question. The answer is, to reassure you, yes, the Earth's magnetic field has changed, and it's changed many times in the past. And it used to change on the rate of about once every 100,000 years or so, but we haven't had it change for quite a while. It's overdue, and we're probably overdue by 700,000 years or so. So it could be happening any time soon. How do we know it's happened? Well, when rocks bubble up as magma from the centre of the Earth, or from the deeper layers of the Earth, and they solidify on the surface, they're solidifying in the Earth's present magnetic field. And because there are magnetizable materials in that molten rock, they will solidify in sync with the present Earth's magnetic field. And this means if you come along with a sensitive magnetic instrument, you can look at where the magnetic field was pointing when that rock was liquid. You can then ask, how old is that rock, which we can do by dating it using various means, including things like uranium, lead, radioactive dating, for example. And therefore you know what the Earth's magnetic field was doing at time X in the past. And that's how scientists have been able to build up a profile of what the Earth's magnetic field has done. We don't know exactly how the Earth's magnetic field works, but we're absolutely sure that it's something to do with the molten iron core in the centre of the planet, which is spinning and giving rise to what we call a geodynamo, and this creates the effect of having a big bar magnet inside the Earth with the North Pole upwards, South Pole downwards, but periodically shifts in the way that that material rotates could lead to the magnet inverting itself, as it has done in the past, and it is slowly wandering. So if you look at where the North Pole of the planet is, it's not in the same place as where magnetic north is.
Yeah.
And if you look at a map, you'll see that there's a direction that says true north or grid north on a map, and then you'll see an arrow off to one side pointing off saying magnetic north, and that you have to correct your compass by the difference between those two when you're navigating on a compass on a map.
If the poles flipped, would it be catastrophic? Would it be the end of us?
Well, I don't think so, because we know for a fact that this has happened in the past many times and during the time that life has been evolving on Earth, including our human ancestors, many of which were knocking around in South Africa when all this would have been happening. Okay. So I think the answer to that question is that it's survivable, but it will confuse some creatures. There are many creatures that rely on the Earth's magnetic field. Birds migrate using the Earth's magnetic field. Fish migrate using the Earth's magnetic field. We don't think humans do anymore. Perhaps our ancestors did, but there are many animals that do. Even bacteria use the Earth's magnetic field to get around or to adjust their orientation. So it might confuse things, but probably it'll happen more slowly than they can adjust to. So they'll be okay.
Yanis in Pretoria, good morning.
Good morning. I just wanted to find out the polar vortex that caused all that cold weather over America. What caused it, and what influence did it have on the polar region? Did it heat up the polar region due to all the cold air moving away, or wasn't there any effect on that area?
Great question, Yanis. Chacha, listen on the radio. Chris?
Hi, Yanis. Well, we know that the Earth's weather has been completely mad in recent years. You just have to take a look around the planet and you see that last weekend New York was enjoying balmy temperatures of 13 to 15 degrees C in Central Park. And then at the first part of this week, it suddenly became minus 15. Chicago is having the coldest winter it's ever had, or at least for 20 years. It's minus 26. And the Philippines have been ripped apart by a massive typhoon in recent weeks, and Britain has been lashed with this tremendous storms which have seen the coastal areas washed away, huge storm surges, houses inundated with water, and so many countries are experiencing freaky weather. And we're not exactly sure why this is happening. It may well be that there's some sort of cycle that the planet goes through, and we're in a phase where it's driving funny weather. But the bottom line is that there are circulating air currents which deliver hot and cold air around the surface of the Earth, and they normally confine themselves to one part of the planet, and periodically they migrate from their usual path and can move to lower latitudes. And if they do that, they then deliver their cooler air to those latitudes and will have a corresponding knock-on effect for the weather. And as a result, you see areas that should be much warmer suddenly becoming a lot cooler, or areas experiencing a lot of rain when they would normally be experiencing a warm, dry summer. So this does happen from time to time. It's certainly not unknown. Whether we're seeing the beginnings of some kind of man-made effect, I think that's something that's a different question. But at the moment, this is because of air masses moving around the surface of the Earth, and they occasionally do that partly because of long-term cycles in the way the planet is in relation to the sun and the energy input to the Earth.
Great question from Pam on SMS. Why do human beings have different blood groups, and do other animals have different blood groups?
Hello, Pam. The answer is that animals definitely have different blood groups, like we do. I think sheep have 4 blood groups, but I might be wrong. Humans have A, B, O and AB blood groups. We think this is merely an effect of genetic diversity, in the sense that although all our human ancestors came from Africa, they then moved away from Africa and diverged across the Earth's surface, and people got isolated in little remote populations, and certain groups would have survived, others wouldn't, and this led to a genetic diversification, and we've ended up with this pattern of 4 blood groups. And what a blood group means, put simply, is that there are chemical markers on the surfaces of your red blood cells, which are either a chemical marker called A or a chemical marker called B, and some people have just A markers, some people have just B markers, some people have both A and B markers, and they're group AB, and some people, like me, have no markers, and they're group O. And people who have those markers will have corresponding antibodies against the markers that they don't have. So people who are Group O will have antibodies against Group A and Group B, so they can't have blood from people who are Group A or Group B. People who are Group A will have antibodies against B. People who are Group B will have antibodies against Group A. And the lucky universal recipients are the Group AB people, because they have no antibodies against either of those two markers for obvious reasons, because they'd attack their own blood cells. So they can have blood from anybody. Aren't they lucky?
Interesting. Chris, we're going to have to leave it there, but thank you very much. We'll catch you next week, yeah?
All right then. Bye everybody. Have a great weekend. See you next time.
Ciao, ciao. 22 minutes
Bye-bye.
after 10. I did say it is a busy hour. We go straight from the Naked Scientist to our Transport Minister, Dipuo Peters.